Hi everyone and welcome back to another lab. In today's video, we are going to show you how to configure and verify the router ID in OSPF. So the OSPF Router ID is a crucial part of the OSPF protocol as it uniquely identifies each router within an OSPF area. So by the end of this video, you will be able to learn how to configure and verify the OSPFv2 Router ID. You will understand how to manually assign a router ID to ensure that each router in the OSPF domain is uniquely identifiable. You will also gain experience in verifying the router ID configuration using various CLI commands and troubleshooting potential issues, such as router ID conflicts or adjacency formation problems. You will also be able to explore how to modify the router ID and ensure that OSPF processes operate smoothly following changes. This lab will help solidify your understanding of how the router ID impacts OSPF functionality and its importance in maintaining stable routing operations. So we will briefly walk you through what is the router ID in OSPF. Then, as usual, we will go through the lab topology and lab objectives. Next, I'm going to cover the lab tasks, and finally, we will walk you through the lab solution. So the router ID is a unique identifier that is crucial for the proper operation and management of OSPF network. The router ID is a 32-bit number written in the form of an IPv4 address that uniquely identifies each router in an OSPF network. While the router ID is expressed like an IP address, it does not need to correspond to an actual interface IP on the router. The primary function of the router ID in OSPF is to distinguish each router within an OSPF domain. OSPF is a link state routing protocol and it relies on the exchange of link state information between routers to build a comprehensive view of the network topology. The router ID is used to uniquely identify each router in the link state advertisements that OSPF routes exchange. This allows OSPF to ensure that each router in the network is recognized and its routing information is correctly processed. Since OSPF uses the router ID to differentiate between routers, it is essential that no two routers in the same OSPF domain have the same router ID, as a duplicate router ID would lead to routing issues and could cause instability in the network. Okay, so how the router ID is determined. So by default, if the router ID is not manually configured, OSPF automatically selects the router ID using a specific process. If an administrator manually assigns a router ID using the router ID and then the router ID command, OSPF will use the manually configured ID. However, if the router ID is not manually configured, OSPF will choose the highest IP address of any active loopback interface. Loopback interfaces are preferred because they are typically more stable and always available, even if other physical interfaces go down. If there is no loopback interface, OSPF will use the highest IP address on any of the router's active physical interfaces. This automatic selection ensures that a router ID is always assigned, but it also means that an interface's IP address can influence the OSPF process, making it a good practice to explicitly configure the router ID. Okay, so with that being said, let's move into the lab topology. And as you can see on the screen, we have 5 different routers that will be used to connect 5 different networks. So if we were to look at the left-hand side of the topology, you can see that router 1 is connected to switch 2 and switch 1, and also is connected to router 2. So the switch 1 is connected to PC1, and this network segment is going to be part of the 192.168.10.0/24. And switch 2 is going to be connected to PC2, and this network segment is going to be part of the 192.168.20.0/24. We can see that router 1 is connected to router 2 via serial 0/3/0, and that network is going to be point-to-point and is going to be part of the 10.0.0.0/30 network. Router 2 is then connected to switch 6, and switch 6 is connected to other 3 routers. So we can see it's connected to router 3, is connected to also router 4, and is connected to router 5. So router 3 is connected to switch 3, and switch 3 is connected to PC3. And this network segment will be part of the 192.168.30.0/24. And router 4 is connected to switch 4, and switch 4 is connected to PC 4, and this network segment is going to be part of the 192.168.40.0/24. And then finally, we can see router 5 is connected to switch 5, and switch 5 is connected to PC 5, and this network segment is going to be part of the 192.168.50.0/24. We will configure OSPF process across all routers, and the OSPF type between router 1 and router 2 will be point-to-point OSPF network type, and between router 2 and router 3 and router 4 and router 5 will be OSPF broadcast network type. And again, all in devices are pre-configured with the appropriate IPv4 address settings, and they are good to go. Okay, so regarding the lab tasks, we will start by configuring all the LAN interfaces across all routers with the appropriate IPv4 address settings. Then we move to step number 2, where we are going to do the same but on the WAN side. Then we will jump into step 3, where we are going to configure the multi-access network across router 2, router 3, router 4, and router 5 with the appropriate IPv4 address settings. Then we're going to move to step number 4, where we are going to enable OSPFv2 across all routers and enable all network to be part of the OSPF process. We will then do some in-flight checks and figure out which router is the DR and which router is the BDR. We will then reset the OSPF process so that all routers reinitiate the election process for the DR and the BDR. Then we're going to look again at the DR and the BDR routers, and from there we will go to step number 5, where we need to configure router ID manually on router 2 and router 3, and then we will need to reset the OSPF process once again for the change to take effect. Then we will revalidate our configuration, and then finally we're going to initiate some connectivity tests, and then we will save our configuration, and that will be the end of the lab. Okay, so this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the first task, where we are going to configure the LAN interfaces on each router. So I'm going to start with router 1. And then I'm going to go to global config. And then I'm going to set the interface ID to interface gig ethernet 0/1. I'll set the description, and I'm going to say link to switch 1. I'll set the IP address, which is 192.168.10.254/24. And then I'm going to enable the interface by saying no shutdown. And then I am going to repeat the same thing for interface gig ethernet 0/2, which is the link that connects the switch to. And then I'm going to enable the interface as well. And then after that, I'm going to create a loopback interface 0. And I will set the IP address with 1.1.1.1, and the subnet mask is /32. Let's quickly verify our configuration. So you can see that I've configured these two interfaces, gig ethernet 0/1 that is connected to switch 1 and gig ethernet 0/2 that is connected to switch 2. And each interface is assigned the appropriate IP address. And you can see that both of them are in the up state. The same applies for loopback interface 0, has an IP address of 1.1.1.1, and also it's in the up state. So I'm going to jump into router 2 and create only a loopback interface. So I'll go back to my topology, I'll go to R2, and then I'm going to go to user privilege and then global config, and I'm going to say interface loopback 0, and I'm going to set the IP address with 2.2.2.2/32. You can see that the interface has been created and the appropriate IP address has been assigned to the loopback interface. I'm going to jump into router 3 next and do the same thing. I'll set the description with a link to switch 3. I'll set the IP address with 192.168.30.254 and then /24, which is 255.255.255.0. Let's enable the interface. And then let's create a loopback interface. And let's assign the IP address with 3.3.3.3/32. Let's do in-flight checks. And you can see that we have assigned the 192.168.30.254 to Gig Ethernet 01, which is the interface that is connected to switch 3. And right now it's in the up state. The same applies with the loopback interface, which has an IP address of 3.3.3.3, is also in the up state. I'm going to jump into router 4 next and do the same thing. Let's set the description. And I'm going to set the IP address with 192.168.40.254/24. I'm going to enable the interface as well. And then I'm going to create a loopback interface. And I'm going to assign the IP address to that interface with 4.4.4.4/32. You can see that we have assigned 2 IP addresses to 2 interfaces. You've got the Gig Ethernet 01 has an IP address of 192.168.40.254, and the loopback interface 0, which has an IP address of 4.4.4.4, and both of these interfaces are in the up state. Let's jump into router 5 and do the same thing. Let's set the description as usual. I'm going to say link to switch 5. I'm going to set the IP address with 192.168.50.254/24. And let's enable the interface and then create a loopback interface and assign the IP address accordingly, which is going to be 5.5.5.5. And the subnet mask is going to be 255.255.255.255. And then let's issue the show IP interface brief. And again, you can see that we have assigned the appropriate IP address on each interface. So what I'm going to do next, I'm going to initiate a ping from each end device to its default gateway, just to make sure that the local connectivity between the end device and the gateway is operational and up and running. So I'm going to go back to my topology and I'll start with PC1. Then I'll go to desktop and then command prompt. And from there, I should be able to ping the default gateway, which is 192.168.10.254. And you can see that we have successful ping. Let's do the same thing on PC2. I'm going to say ping 192.168.20.254. We can ping the default gateway. And I'm going to do the same thing on PC3. And I'm going to say 192 or ping 192.168.30.254. We also have connectivity and reachability between the end device and the default gateway. So let's do the same thing on PC4 quickly. I'm going to say ping 192.168.40.254. And we also have connectivity. And our final test is going to be with PC5. So I'm going to say ping 192.168.50.254. And we also have reachability and connectivity, as you can see on the screen. Okay, so next I'm going to jump into task number 2, where we need to jump into router 1 and router 2 and configure the WAN interface, which is serial 0/3/0. We're going to configure each interface with the appropriate IP address, and we're going to enable the interface as well. So I'm going to go back to my topology, and I'm going to go to R1, and I'm going to global configuration, and then from there I will set the interface to serial 0/3/0. Let's set the description. I'm going to say link to R2. Let's set the IP address with 10.0.0.1, and that is going to be /30, which is going to be 255.255.255.252. And then we're going to enable the interface by saying no shutdown. Let's do the same thing on router 2. So I'm going to go to global config, and from there I will say interface serial 0/3/0. Let's set the description with link to R1. Let's set the IP address with 10.0.0.2/30. And then let's enable the interface by issuing the no shutdown command. And now if I say show IP interface brief, we can see that this interface has an IP address of 10.0.0.2. And right now you can see it's in the up-down state. However, we just received a log message that's indicating that the interface now is in the up-up state. So if I up arrow that again and execute that command, you can see that this interface now is in the up-up state. So I'm going to jump back to router 1 and do the same thing. So I'm going to say show IP interface brief. You can see that this interface now serial 0/3/0. It's in the up state. Let's initiate a ping from router 1 to router 2. So I'm going to say ping 10.0.0.2. And we have reachability and connectivity between router 1 and router 2. Okay, so what I'm going to do next, I'm going to issue the show IP route to reveal the routing table and see what's in there. So I'm going to say show IP route. So as you can see on the screen, all the IP addresses that we configured on each interface, you can see that the network address has been populated and listed in the routing table. So for instance, we can see that 1.1.1.1/32 that is associated with loopback 0. We also can see that 10.0.0.1/32 is associated with serial 0/3/0. The same applies with the LAN interface, which is connected to switch 1, has an IP address of 192.168.10.0/24. And finally, the interface that is connected to switch 2 is associated with this network address, which is 192.168.20.0/24. So next I'm going to jump into step 3, where we need to configure the multi-access network, which is between router 2, router 3, router 4, and router 5. So I will jump into router 2, and I'll start with router 2. So I'm going to go to global config, and I'm going to say interface gig ethernet 0/0. I will again set the description with link to switch 6. Let's set the IP address with 10.10.10.2, and that's going to be /29. I'm going to issue the no shutdown to enable the interface, and I'm going to hit end. I will jump into router 3 and do the same thing. I'm going to say interface gig ethernet 0/0. I'm going to set the description with link to switch 6. I'll set the IP address with 10.10.10.3. And the subnet mask is 255.255.255.248. And let's enable the interface. And repeat the same thing on router 4. Let's set the description to link to switch 6. And I'm going to set the IP address with 10.10.10.4. And then let's enable the interface. And then finally, let's jump into router 5 and do the same thing. going to set the description with link to switch 6. Let's set the IP address with 10.10.10.5. And the subnet mask is 255.255.248. We need to enable the interface. I'm going to then hit end. So I will go to router 2 and perform the in-flight checks from there. So I'm going to say show IP interface brief. You can see that the gig Ethernet 0/0 is in the up state and has an IP address of 10.10.10.2. And what I'm going to do next, I'm going to actually initiate a ping between router 2 and router 3 and router 4 and router 5. So I'm going to say ping 10.10.10.3 and I can reach router 3. I'm going to up arrow this and I'll change the last octet to 4 to try to ping router 4. And I'm also able to ping router 4. I'm going to do the same thing with router 5. And we can ping router 5 as well. Next, I'm going to jump into step 4, where we need to enable OSPF across all routers. So I will start with router 1. And from there, I'm going to go to global config, and I'm going to say router OSPF1. And I'm going to say network 0.0.0.0.0. And the wildcard is going to be 255.255.255. And set the area to 0. And this command will enable all interfaces to participate in the OSPF process. Then I'm going to hit enter, and then I'm going to hit end, and I'm going to do some in-flight checks. So I'm going to say show run pipe section router, and you can see this is the OSPF configuration on router 1. I'm going to jump into router 2 and do the same thing. So I'll go back to global config, and from there I'm going to say router OSPF2, and I'm going to set the network with 0.0.0.0, and the wildcard is 255.255.255.255. I'm going to set the area with 0. Now you can see instantly we have formed an adjacency between router 1 and router 2. So I will do the same thing on router 3. So I'm going to jump into router 3 and do similar configuration. I'm going to say router OSPF3, and I'm going to say network 0.0.0.0, and the wildcard is going to be 255.255.255.255, and this network is going to be in area 0. I'm going to hit enter, and then I'm going to hit end. And if we wait a few seconds, you can see that we have formed an adjacency with router 2. Since we know that neighbor ID for router 2 is 2.2.2.2. So I'm going to jump into router 4 and do the same thing. I'm going to say network 0.0.0.0, and the wildcard is 255.255.255.255. It's going to be in area 0. I'm going to hit end. And then if we wait a few seconds, we should be able to form an adjacency with router 2 and router 3. As you can see on the screen, we have formed an adjacency with router 2 as well as router 3. Now I'm going to jump into router 5 and do the same thing. So I'm going to say router OSPF5, and I'm going to set the network with 0.0.0.0, and the wildcard is going to be 255.255.255, and the area is going to be 0. I'm going to hit end and just wait a few seconds. Okay, so we have formed an adjacency with router 2 and router 3. So I'm going to go back to router 2, since router 2 is formerly the router that resides in the center of the topology. So from router's 2 perspective, we should be an adjacent with router 1, router 3, router 4, and router 5. So if I say show IP OSPF neighbor, so you can see that we are neighbor with router 3. We also neighbor with router 4, router 5, and router 1. So if I were to then reveal the routing table to check if we have received all networks from our topology, so let's do that. So I'm going to say show IP route. So if we were to examine the last 5 entries, we can see that these entries have been learned via OSPF, as you can see the O sign from the left-hand side. And you can see the network IP address is 192.168.10.0/24, as well as the 192.168.20.0/24. Both networks have been learned via router 1, and you can see to reach them, you have to use the serial 0/3/0 interface. Similarly, with the 192.168.30.0, in order for you to reach that interface, you would have to exit via the Gig Ethernet 0/0. And the same applies with 192.168.40 and .50. And you can see that each network that we have learned is from a different router. So the first 2 networks is from router 1, the third network is from router 3, and the fourth network is from router 4, and the fifth network is from router 5. We also have learned the loopback interfaces from each router. So for instance, we know now how to reach 1.1.1.1. We also know how to reach 3.3.3.3. And the same applies with 4.4.4.4. And finally, how to reach 5.5.5.5 network. So next, what I'm going to do, I'm going to reveal by default, now that we have configured OSPF across all our topology, let's verify who is the DR and who is the BDR as we speak. So I'm going to say show IP OSPF interface Gig Ethernet 0/0. This is the interface that is associated to multi-access network. So I'm going to hit enter, and you can see that this interface belongs to area 0, has an IP address of 10.10.10.2/29, and right now it is configured under OSPF ID 2, and the router ID for this OSPF process ID 2 is 2.2.2.2, and the network type is broadcast. Now, if we were to look at these 2 data, we can see that the designated router is 2.2.2.2, which means it's the local interface, because we know that the local RID is 2.2.2.2, which means router 2 is the designated router, and the backup designated router is 3.3.3.3. So this is by default, it picked router 2 and then it picked router 3. And the reason being is because if you think about it, we have actually configured router 2 first and then router 3 second. However, if we were to reset the OSPF process, this will actually change. So let's do that, and let's verify what is going to be the default behavior when it comes to electing the DR and BDR. So I'm going to say clear IP OSPF process. So before I actually go ahead and issue this command, I want to clarify that issuing this command in a production environment will disturb the network. So please do not try this unless it's under a change window and that you are aware of the consequence of what you're doing. So this command will reset the OSPF process. So all the neighborship between router 2 and all its neighbors will be teared down, and then it will be re-established. So I'm going to go ahead and hit enter, and then I'm going to say yes. So as you can see from the screen, the neighbor relationship have been toned down and then brought back up again. So what I'm going to do, I'm going to issue the same command. So I'm going to say show IP OSPF interface Gig Ethernet 0/0. And this time you can see that the designated router still remain the same, and the backup designated router still remain the same. So what I'm going to do next, I'm going to actually jump into router 5. And from there, what I'm going to do, I'm actually going to issue the clear IP OSPF process. And I'm going to say yes. And let's see what is the behavior of electing the DR and the BDR. So what I'm going to do, I'm going to say show IP OSPF interface Gig Ethernet 0/0. So you can see from this output that router 5 is the actual designated router. And what I'm trying to demonstrate in this lab is that you don't want the OSPF to actually be in charge of that. You want to influence how the designated router is elected and the backup designated router is elected. So you can see that the designated router is 5.5.5.5 and the backup designated router is 3.3.3.3, which is router 3. If I were to jump to router 3 and do the same thing, so I'm going to say IP or clear IP OSPF process, and I'm going to say yes. Now just let's wait a few seconds, and I'm going to issue the show IP OSPF interface gig Ethernet 0/0. So now what you see is that the designated router is 5.5.5.5 and the backup designated router is 4.4.4.4. This is usually what we expect since router 5 has the highest RID and the second highest RID is router 4 since the router ID is 4.4.4.4. So with that being said, let's move into the next step from the lab tasks where we are required to configure manually the router ID on router 2 and router 3. As you can see, the current designated router is router 5 and the backup designated router is router 4. But let's say that we want router 2 and router 3 to be the actual DR and BDR. So I'm going to go back to router 2 and I will go to global config and I'm going to say router OSPF2 and I'm going to say router ID 200.20.20.20 and then I'm going to hit enter. And as you can see, we have received a message saying that reload or use clear IP OSPF process command for this to take effect, which means although I have configured the router ID under the OSPF ID in question, that actually hasn't changed anything. So if I hit the show IP OSPF interface gig Ethernet 0/0 and I hit enter, you can see that the current RID or router ID is still 2.2.2.2. So if I want that to change, I would have to either reload the router or use the clear IP OSPF process command. I'm going to repeat the same thing on router 3. So I'm going to go to global config and I'm going to say router OSPF3 and then after that I'm going to say router ID 130.30.30.30. Again, we get the same message, and if I issue the show IP OSPF interface gig Ethernet 0/0, we can see that the router ID still remain the same. And what I'm going to do, I'm going to go ahead and clear the OSPF process. So I'm going to say clear IP OSPF process. I'm going to say yes. And then I'm going to up arrow that multiple times to get to this command. And I'm going to hit enter. And right now you can see that the designated router is actually 130.30.30.30, which is router 3, because the current router ID is 130.30.30.30. And the reason being is because the router ID for router 2 hasn't actually changed yet. So I'm going to go back to router 2 and do the same thing. So I will say show IP OSPF interface gig Ethernet 0/0. You can see the router ID still hasn't changed. So what I'm going to do, I'm going to say clear IP OSPF process. I'm going to say yes. Okay, so what I'm going to do, I'm going to say show IP OSPF neighbor. You can see that we are neighboring with router 3, router 4, router 5, and router 1. And then after that, I'm going to say show IP OSPF interface gig Ethernet 0/0. And right now you can see that the designated router is 200.20.20.20. And for some reason, it picked the backup designated router with 4.4.4.4. So that could be a bug within Packet Tracer or a limitation within Packet Tracer. But in reality, it should have picked up the router 3 since it has the highest router ID. But what I'm going to do, I'm going to go back to router 3 and try to force this again. So I'm going to say clear IP OSPF process. I'm going to say yes. And let's see this time who is the DR and who is the BDR. So I'm going to say show IP OSPF interface gig Ethernet 0/0. And right now you can see the designated router is actually 200.20.20.20, which is what we expected. And you can see also the backup designated router, which is 130.30.30.30. Now that we have confirmed that the designated router is router 2 and the backup designated router is router 3, we can then proceed with the next step where we need to initiate a ping request from PC1 to PC2, PC3, PC4, and PC5. So I'll go back to PC1 and I will up arrow this to try to reach the PC2. So I'm going to say 20.2. And we have reachability to PC2. I'm going to do the same thing with PC3, and we can reach PC3 as well. I'll do the same thing for PC4. Right, so for some reason we can't reach PC4. I'm going to try PC5. And again, we can't reach PC5. So what I'm going to do, I'm going to start troubleshooting. So I'm going to go to router 1 and make sure that we actually can see these networks in the routing table. So I'm going to say show IP route. And here I can see network 30 and network 40 and network 50. So we should be able to reach these networks via serial 0/3/0. So let's go to router 2 and reveal the same thing. So I'm going to say show IP route. So we can see all these networks again have been listed in the routing table. So let's go to router 3 or router 4 actually. Let's make sure that we can send the traffic back to router 1. So I'm going to say show IP route. Okay, so I can't see. So I can't see the 192.168.20.0 network and .10. So what I'm going to do for the sake of it, I'm going to say clear IP OSPF process. Let's try to do this. And then I'm going to reveal the routing table again. And this time we can see the OSPF have learned about network 10 and network 20. So I'm going to go back to router 5 and do the same thing. I can see network 192.168.20 and .10 are missing from the routing table. So I will do clear IP OSPF process. And now we can see that we have learned about the 192.168.10 network as well as .20 network. So I will go back to PC1 and I will repeat these commands. So ping 192.168.40.4. We have reachability and connectivity between PC4 and PC1. So I will up arrow that and I will get to ping 192.168.50.5 command and I'm gonna hit enter. And we can reach PC5 as well. Okay, so at this stage, you can go ahead and save your configurations, and that is the end of this lab. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.